This video is sponsored by Brilliant.org. I have always had a small obsession with stage lighting and disco lights. I don't know why, I've just always liked those big lights, specifically ones you can control and synchronize to music. In some of my really old videos, you can see this big lighting stand behind me that I had in my bedroom with various things hanging off it. I had a strobe light and a light sequencer and this thing called a wildflower. Most of those lights are now in my parents' loft, along with the lighting stand. Not in my bedroom anymore, which is probably for the best. However, I did bring two lights to London with me, specifically the American DJ Mega Par Profile and Mega Par Tri-Par Profile. Most of those lights you see in the background of my old videos I got when I was like 6 or 7. These ones I bought in 2013 and 2014, so I was at uni at this point. I had no good reason to buy these lights, I just thought they looked fun. Anyway, here they are. Well, actually these are just the boxes for them because they're actually plugged in behind this sofa. There's the Mega Tri-Par Profile, and hiding in this corner is the almost identical but slightly older Mega Par Profile. So with them behind the sofa like this, what we can do is turn them on over here, and it's not quite the disco that they were destined for, but it lights up the window frames. It's slightly more noticeable when it's actually dark outside. Yeah, that's a terrible example, but you get the idea. So this setup works. You have to go over there to turn it on, and it's all probably a bit more effort than it's worth. You'll see next to this light we have a Roomba, and Roomba relentlessly bashes into the lights every day as it goes around hoovering. So the lights have to be really strongly blue tacked to the floor. Same with this one, and then the cables that connect them together are taped up underneath the sofa here. And even still, Roomba manages to rip it all down every few months. Nevertheless, this is what I've got, and I want to integrate it into my home automation system so it's a bit more controllable and usable. The two lights are connected together so they both show the same thing. You just configure one of them, then the other one copies. And that's because they are DMX lights. DMX 512 is a protocol from like the 80s, and according to Wikipedia, it's a standard for digital communication networks that are commonly used to control stage lighting and effects. So professional lights, most kind of like DJ lights, theatre lights, all connect together with DMX cables, which are basically the same as XLR cables. For a while I've had this DMX to USB adapter. Little metal box with DMX on one side and USB-B on the other side. So currently the light down there acts as the master and the other one is the slave. What I can do instead though is set them both up to be slaves and have a more intelligent master, i.e. a Raspberry Pi. I've got a Raspberry Pi here. Using this, the idea is I can connect them all together and it'll work. We'll give it a go. The first thing to note about the hardware is that this company called Entech make DMX to USB interfaces, and they've got this open DMX USB thing here and then the DMX USB Pro. Very unclear what the differences are beyond the second DMX connection that the Pro one has. But it boils down to the Pro version having some kind of microprocessor inside which handles some stuff that this one doesn't. It mentions internal frame buffering. I don't really know what any of this means, but I know that I have an OpenDMX compatible interface. It's not actually from Entech, but I remember the eBay listing when I bought it said it was compatible with OpenDMX. In fact, I can probably find the email. Yep, there it is. In 2013, I bought USB DMX 512 interface controller, Entech Open Compatible, whatever that means. So I can connect these things together and I can connect it to the light and I can put the light into DMX mode as a slave. And what I found yesterday when I was looking at this in a bit more detail was this Python library called Simple Dmx. It's not the best code I've ever seen. The examples don't actually work. There are some bugs in the code, but I'm glad this stuff is online, so I don't have to figure it all out from scratch. And the way it works is really simple. It just sends some packets which have some bytes in which represent some DMX values, and it sends it over the USB interface. And it should work. I have already tried this with a Raspberry Pi with them all connected together, and I got absolutely nothing. The little light on this thing would flash, presumably indicate that data is going through it, but the lights did nothing. They stayed off. For some background on DMX, you have what is called a universe. And one cable can control one universe. If you have multiple universes, you need multiple cables, I think. And you send packets to this universe through the cable, and each one has values for up to 512 channels. And a light can occupy some range of those channels. So these lights have 7 channels, for example. And that's like red, green, blue, master dimmer, strobe, a couple of other things. Every light would be different, and I think you just sort of slot them in wherever you want to this 512 channel range. So using this Python library, you just set some channels manually to values. So like channel 1 would be red, you set that to max. Set channel 7, which is the master dimmer, to max, and it should go red. But it didn't. After a lot of Googling and researching this stuff, I came across this particular Stack Overflow answer, which says, it should be noted that one cannot use normal serial-based libraries with the Open Dmx, or at least the Open Dmx compatible interface. OLA, which is the Open Lighting Architecture, which I'll get to in a few minutes, needs to use a special kernel module on Linux, or the generic FTDI non-serial kernel driver in combination with libftdi on Mac or Linux. I don't fully understand this, but what it is essentially saying is that the Open Dmx things can't use these serial libraries, these really simple versions, and instead you need some kind of kernel module. If I had the Pro version, then it would probably have worked with these simple libraries, but like you saw, that's like £100, and I already have this one. So I then tried to research, how do I get this kernel module that I need? When you start Googling to find how to do DMX on Linux, you might come across DMX for Linux. Turns out this is massively outdated and not maintained anymore. The most modern software I can find is from the Open Lighting project, and as I mentioned, this OLA software, Open Lighting Architecture. And this does all sorts. It supports tons of protocols. It'll communicate directly with DMX devices through various interfaces, including notably the NTech Open DMX USB. It supports higher level protocols like ArtNet as well, which is like DMX over Ethernet, I think, something like that, but we don't need any of these other things. We literally just need this Open DMX ability that it has. And I tried just like apt-get install OLA on the Raspberry Pi, and I couldn't really figure out how to make that work. So I'm going to follow the official OLA on Raspberry Pi tutorial, because that sounds very suitable for what I'm trying to do. Basically, it seems like it's just a modified version of Raspbian where all of this stuff is set up, and this magical kernel module driver thing that I apparently need will exist. It says it'll just boot and then work, like no configuration needed. One thing to note if you ever use this, halfway down the page, it just decides to tell you that by default, the image comes with an SSH key installed for Simon to access the system. If you trust me, and you probably do since you're running my code, you can leave this on. Otherwise, you can delete my key. I have no idea why this operating system would come pre-installed with access for Simon. Who's Simon? Okay, if I crouch in this corner, I can plug all of this stuff in. I've got the Raspberry Pi with this OLA Raspbian edition on it. This is an original Model B, which means it doesn't have Wi-Fi. And I did used to have a Wi-Fi dongle for it, but it broke. I don't know how, it just stopped working. And what I do have is this TP-Link nano router, which can act basically as a massive Wi-Fi dongle. So I'm gonna rather comically use this. So we've got Ethernet. We can plug in this DMX adapter, plug in the lights to this, and plug in the Raspberry Pi. All of this is not going to fit into this little box. I turn it on, the light will come on because it's just configured to be like orange all of the time. And there's a button on the back, and I can't see the screen because it's also on the back and it's blue tacked to the floor. But I think when it goes off, there we go. That is DMX mode. So the Raspberry Pi should be booting. Let's see if we can SSH into it. Or better yet, let's try the web interface that it apparently has. At port 9090, Oh my god, it actually works. Okay, that's cool. Progress. There's not much to it. We've got universes of which there are none, and plugins of which there are some. Now there's an Entech Open DMX plugin. And there's an add universe button. I have no idea what I'm doing. Disclaimer, this is not a tutorial anymore. I did read somewhere in the docs that universes should start at 1, not 0. Then we select ports. None of them really look like my device. There's a dummy device. What does that give us? Oh, it gives us sliders and stuff to control the lights with, but presumably this does nothing. No. Okay. The Entech Open DMX page, it says it's enabled and active, and it says device equals /dev/DMX0. I wonder if that needs to be set to what the device path actually is, because it's going to be on some USB path. Okay, I'm SSH'd into the Raspberry Pi. We can go to this OLA conf folder. Okay, that's the config. I reckon this should be like USB/USB. I can't quite remember what this should be. How do we find this out again? I think there's a command called Dmx, and this outputs loads of like logs, I guess, from device drivers. There we go. USB serial device converter now disconnected was apparently the latest message. Really? Okay, now attached to TTY USB 0. So if we update this to /USB/TTY USB 0, reload plugins, I guess. What happens if I look in this list now? Nothing has changed. Oh, I see why. This is meant to be dev/. I don't know how to do Linux. Oh, we've got something. OpenDMX USB device as an output. So now we've got a universe. It's recognized this thing as OpenDMX at the right place. Does it work? No. The light is not doing anything. Oh, that's a shame. I thought that was going to be it. Oh, it's now got it as a new device, Stage Prophy, on TTY USB 0 as well. What happens if we add that? No, still nothing. You should see lights coming up from behind me when this works. I'm gonna have to look into this more and get back to you, I think.
2 hours later.
I've done a lot of Googling and playing around with this. And I've come across this blog post by a guy called Martin Higgins. And I think he may have just saved this project. He's trying to do a very similar thing with an Entech OpenDMX USB serial converter with a Raspberry Pi running OLA. And he writes, after a little bit of trial and error, I managed to get the Raspberry Pi to communicate with the OpenDMX USB. After a while of thinking that it needed to use Entech OpenDMX plugin, obviously because that's like the one where the name matches, I found through experimentation that if you disable both the Entech OpenDMX and serial USB plugins and enable the FTDI USB DMX plugin, then it works perfectly. How could I have possibly known this? So disable the Entech one and disable the serial USB one. Enable FTDI DMX one. Reload. My universe now has no inputs or outputs. We've got USB to serial with serial number blank as an output. It's dead. The universe is gone. Let's add a new universe. Okay, we've still got this USB serial with serial number nothing. DMX console. Oh my god! Can you see that red on there? It works. I can actually control it. I can add like green or blue. It's really fiddly. One of these is a strobe setting, that one apparently. Or there's some like color macros which do various things, and it's just really cool. I'm so glad that this works. This was so hard to figure out. I've spent hours researching this. Thank you, Martin Higgins, for your blog post. Okay, if I turn all these down again, it should go off. I need a more programmatic way to control this now, instead of this web interface. I saw on the Open Lighting website that they've got some APIs. There's a C++, a Python, and a basic Java API, which is apparently not documented. I have no idea how fully featured these are, or whether they work, or whether it's worth doing. It would be nice though if I could use these official programmatic APIs, basically write my own service, which then sits on this Raspberry Pi, calls these Python APIs, or C++, whichever ones work, to control this thing. Oh, I've just found some command line tools that this OLA system has as well. Have I got a command called OLA streaming cloud? Oh, I do, it's actually installed. This Raspbian image is like way more fully fledged than I expected. I thought everything would be like half broken, but everything just works out of the box. It's amazing. I mean, apart from the fact that it's non-intuitive and super hard to understand how to use, it's great. So I think this is universe 1, and then some DMX data. So if we sent like 200 red, green, 2, 3, 4, 5, 6, then the master channel. Oh my god, it worked! Haha! I could do this instead of the programmer, the API. I could just call this command line tool if all else fails. Like, API would be better. It's probably got more features. It's probably got some less overhead, at least, if I want to do like fades and stuff where I'd be sending loads of requests to loads of packets to the light. But this is a good option. I've got something. This is good news. It's guaranteed to work now, as long as this software is reliable and can sort of just stay running full forever. Oh, I love it. This is already an easier way to control it than trying to press those buttons on the bottom that I can't see. As I mentioned earlier, this box of cables is a bit ridiculous. None of this fits, particularly with the nano router being the Wi-Fi dongle. I think this is an opportunity to buy a Raspberry Pi Zero. I ordered the Raspberry Pi last night, but it won't arrive for a couple of days. But in the meantime, I want to try to write some of the code that I need for this project. And ideally, I want to do it without needing to be SSH'd into a Raspberry Pi running this OLA software. I've got the instructions for the light here for reference. My first thoughts are, can I Dockerize the whole thing and solve it that way? Oh, we have a couple of results here. That second one has the most pulls and a Docker file, and this is installing the OLA software. But I've got service.controller.dmx, which is going to be this particular service which runs on this new Raspberry Pi. The first thing I want is a Docker file with this in it. I can see this has an entry point. I don't know what start.sh does. It probably runs the OLA software. I don't know if we need to. I also can't remember the difference between entry point and command. I think entry point is more for running the image as an executable. Maybe I can set a command like this. We'll see what happens. I'm copying this from code I've written before because I know that it works. I also know that I need Python 2.7 for this project, just because that's what the libraries I'm going to use are in. So first let's just take some examples from the Open Lighting documentation and see if anything runs at all. Sending DMX is what we want. So with some luck, this will exist inside of the Docker container. And what they're doing, they've got a function called DMX sent, which does wrapper.stop. Universe is 1. Data is some kind of byte array. I don't do anywhere near enough Python to be fluent in this language. But we instantiate a client wrapper and do send DMX, and this must be some kind of callback, I suppose, and then run at the end. So I suppose I can just put this straight in to run.py just to test it. I'll create a Docker compose file just to speed things up a bit and see what this does. Oh, it's doing something. I think it's still running that setup start script. Start. That's the one. Let's remove the entry point. Okay. Failed to connect to OLAD. But that means, I think, that it did find this library, this OLA library. Specifically, it's in user local lib python 2.7 dist packages OLA client wrapper.py. That's perfect. But maybe I do need this service to be running. Trying to run multiple processes in a Docker container is a bit of a pain. I'm gonna have to think about this one a little bit. By think about, I mean Google and the Docker docs have a page on exactly this problem. The advice is don't do it, but in this case it would be really difficult, I think, to separate the Python code into a separate Docker container, because this Python library that it's using is just trying to connect to a locally running instance of OLAD, however they want me to pronounce this. So I'm just going to steal this script. Let's see what that does. Permission denied. Interesting. Okay, I've got something which just about works. I renamed my start script to process manager just to differentiate it from the other start script that the OLA container provides. And now it does this no hang up thing. Runs the shell script which starts OLAD, then puts that in the background. That then runs. It takes a while to start up, so then I just sleep for 10 seconds, and then I run my script. And in the Docker file, I copy this to the root directory. This solves the permissions issue. I can't be bothered to understand why. It matters where this script lives, but then we make it executable and run it, and also continue to set the entry point to blank to override the parent container's entry point. And when we run this, after we build it again, we can see it'll attach and nothing happens for a while because we're in the sleep state, but OLA is starting up. Then eventually we get these two lines here. So another thing that I added was just a print statement, starting DMX service and then DMX service terminating, and some stuff happens in the middle. It does manage to print both of these things with no errors. So I think that's a good thing. The library exists and it's using the library without any errors, and it doesn't really matter during development if I can call send DMX and nothing happens. I can trust that when I do this for real, it will actually send DMX packets to the light. But if it can do this without erroring in dev, then it means I can write the rest of the service and not rely on physical hardware or Raspberry Pis or lights or anything. But it's now 1 minute past 11. I've got work in the morning, so I think this is a good place to stop. Alright, it's Saturday and my Raspberry Pi Zero has been delivered. This is all from ModMyPi, except the SD card, which is from Amazon because it was cheaper and I needed some other stuff from there anyway. With the Raspberry Pi, it's got this, is it mini or micro HDMI adapter to normal size HDMI. Similarly, a little micro USB to normal USB cable, and a box with the Raspberry Pi inside. Oh my god, this thing is tiny! So this is the Raspberry Pi Zero W, the wireless model with Bluetooth and Wi-Fi, with pre-soldered headers. So the pins here, let me zoom in. The pins already exist. I don't have to solder anything in myself. So if I do want to use them, then it's really easy to do that. For this DMX project, I obviously will need them. I need the USB port. There are two USB ports. One is for power, which is that one on the right there. This one is for normal USB, so that works like that. If I wanted to connect it to a monitor, I would do it through HDMI something like this. I didn't get a power cable with it because I think I can just use the one I've got from my original Raspberry Pi. That would be fine. Then the SD card, of course, slots in just at the side there. But first I need to put that OLA version of Raspbian onto this SD card. Unfortunately, it doesn't seem to boot or do anything. The LED just flashes when I put the SD card in, and there's no HDMI output either. So I'm going to try to flash the official Raspbian image to the SD card to see if that boots instead. Okay, the official latest version of Raspbian boots with no problem on the Zero. I reckon the OLA version is just really old, like pre-Raspberry Pi 0, 3, maybe even 2. So I've got two options. I can try to install Open Lighting manually on this official version of Raspbian. There are instructions for how to install it on Linux. I'm going to just try it and see what happens. Maybe something will fail. My backup is not use the Raspberry Pi Zero for this and stick with the older Raspberry Pi and get a Wi-Fi dongle for it. That would solve the problem. Okay, doing apt-get install OLA seems to have worked. So now this is ready to install down here and swap out this older Raspberry Pi. I've got SSH enabled on here, so I'll be able to connect to it. I've set up Wi-Fi, that works really well. For size comparison, it's like 1/3 of the size. It's really cool. I've also got a basic Python service, which I think is ready to run on the Raspberry Pi, and it should let me control the lights via HTTP. Disclaimer, it's actually Sunday now. I've spent longer than 10 minutes doing all of this. I didn't get a case because I thought it would be fine. I'm going to have to be careful not to bend any of the GPIO pins on here. Okay, this just about fits. Turned it all on, that should boot. Let's try it out. Okay, I've written a script in Bash to deploy this service with, which just about works. So I should be able to just do deploy service.controller.dmx. With some luck, this SSHs into the Raspberry Pi and it pulls the latest version of the repository, which is now on GitHub. It installs requirements inside a virtual env for this Python project, and then finally it will configure and enable a systemd service, which means the service can run like in the background as a daemon and on boot as well, which is what I want. So that looks like it's worked. The lights are behind me and plugged in. The Raspberry Pi is on, obviously because I've just deployed to it. I'm going to use port, which is just an HTTP client, and first make a GET request to the service. If I put the right IP address in. Okay, the service is up, it works, it responds. And if I make a patch to the same service and set brightness to 100 and RGB to red as a hex code, this should turn the lights on. Okay, my code has kind of worked. It's tried to validate an argument which doesn't exist. Let's just set strobe to 0 and then I'll fix that later. Did it work? No. Okay, it didn't work. That's disappointing. So I think my code has worked. As in, it's done what I thought it was going to do. Just what I was trying to do is not what I should be doing. Oh wait, hang on, I know. I haven't set up the universe on this Raspberry Pi. Okay, I'm gonna have to do some configuration of OLA. I totally forgot that I hadn't done this already on the new Raspberry Pi. Okay, I've enabled and disabled the right combination of plugins I've set up the universe with the USB output, so that works. Through the interface I can control the lights. Now, if I make my patch request, yes, it works. But let's see if this works properly. Can I set it to green? Yes. And similarly blue, and obviously any color in between. I should be able to set the strobe value as well. There we go. If I ever want strobe lights behind the sofa, then I've got a RESTful API through which I can enable them. Let's turn them off again. Amazing. So, what have we learnt? Open source software is fantastic, even if it does drive you slightly insane. Raspberry Pi Zeros are pretty cool, and having DMX lights in your living room is ridiculous, but if you're willing to persevere, you can make them work. If problem solving is something that you enjoy and you want to do more of it, then take a look at Brilliant.org. Brilliant is a problem solving website, and it's a fantastic way to learn. I have had to solve endless problems while making this video just to literally get 2 lights to turn on. But it means I've learned a bit more about the DMX protocol. I've learned how OLA works, the interface. I've learned a bit more Python, which is not something I typically write day to day. And I've learned what systemd is and how to use it. So actually being faced with all of these problems has resulted in me learning much more about each part of the system than I would have otherwise. And this is the approach that Brilliant takes to learning new skills. They have a huge array of courses. Each one guides you through various problems to help you build up your understanding step by step. Their courses cover maths, science and computer science. They're interactive and beautifully illustrated. For example, this course on algorithm fundamentals. If you'd like to learn more, go to brilliant.org/jakewright. You can sign up for free, see what you think, and the first 200 people who use that link can get 20% off the premium subscription. Alright, I think that's everything. This has been quite a long video, but we're one step closer to a fully automated home. Check back again in a few weeks for the next installment of me wasting my time when I could just use Siri. Thanks for watching.